Question 17, exercise 7.11. Question 17. Integration 0 to a, I will take this as I, 0 to a root x dx upon root x plus root a minus x. So using property 5, I can replace x as a minus x. Give this as 1. So replacing x by a minus x everywhere. So 0 to a root a minus x dx upon, you can see that here a will get cancelled out, and I will have just root x, which I am writing it as first and then second as a minus x, and give this as 2. If I add equation 1 and equation 2, then I will get I plus I as 2I, taking common integration as both of them is having same limits. Root x upon root x plus root a minus x plus root a minus x upon root x plus root a minus x dx. So taking LCM, I will have root x plus root a minus x upon root x plus root a minus x. Cancelling will give me just dx. Integration dx is just x 0 to a. Keeping the value a minus 0, I will get a. But this is the value of 2I. Therefore, I is a by 2. Question 18, sorry. 0 to 4 mod x minus 1 dx. So you know that mod x minus 1 can be split in x minus 1 if x is greater than or equal to 1, and x minus 1 minus x minus 1 if x is less than. So I will split this 0 to 4 as 0 to 1 and 1 to 4. As you can see that in 0 to 1 range, the value of x is less than 1. So here I will take minus, and here the value of x is greater than 1. I will take plus. 0 to 1, 1 minus x dx plus 1 to 4 x minus 1 dx. Now giving individual integration, I will have x minus x square by 2, 0 to 1, plus x square by 2 minus x 1 to 4. Keeping the value of x as 1, I will have 1 minus 1 by 2 minus, keeping the value of x as 0, I will get 0 minus 0. Keeping the value of x as 4, I will get root square 16 by 2 minus 4 minus bracket, giving the value of x as 1, I will have 1 by 2 minus 1. So 1 minus 1 by 2 is 1 by 2, and this is 0, plus this is 8, 8 minus 4 is 4, This is minus 1 by 2, but minus minus it will again get s plus 1 by 4 plus 1 by 2 plus 1 by 2 is 1, and finally my answer is 5. Question 19. Show that integration 0 to a f of x dx is 2 times 0 to a f of x dx. If f and g are defined as they have defined f of x as f of a minus x, give this as 1, and the g of uh, x plus g of a minus x as 4. So I can write g of a minus x as 4 minus g of x. If this as 2, we will use this equation. Now, we will start with the left hand side, which is 0 to a f of x into g of x dx. Using property 5, I can replace x as a minus x. Okay, and g of x as g of a minus x dx. Right. Now, from equation 1 and equation 2, will replace the value of f of a minus x. F of a minus x is f of x, and from equation 2, g of a minus x is 4 minus g of x dx, right? So multiplying will give me 4 times f of x minus f of x into g of x. So giving individual integration, 4 will come out of f of x g of x dx, right? So I will take this as I and will give this equation 3, but from equation 3 you can see that this is the value of I only. So we started with I. Here we have to write and we'll give the result from equation 3. So minus I, it will go over here, it will become 2I. Therefore the value of I is 202a f of x dx, which is our right hand side, hence 2. Question 20. This question is in multiple choice form, that is MCQ form. We are asked to find the value of minus pi by 2 to pi by 2 integration x cube plus x cos x plus 10 raised to 5x plus 1 dx. Now, as it is minus a to a, we can apply property 8 over here, but before I apply that property 8, I have to make some arrangements. We'll separate this last term from integration. Means I will give this individual integration to 1. If I assume f of x as x cubed plus x cos x plus 10 raised to 5x, and if I replace x by minus x, then this is minus x cube minus x cos is even function, I will just have x, and 10 is odd function again, minus 10, and raised to odd power will give me minus 10 raised to 5. So if I take minus common outside from this, then this is minus f of x. As you can see that f of minus x is minus f of x. The integration of this will be 0, and the integration of this is x minus pi by 2 pi by 2. Here we will write by using property A. Right. So if I keep the first limit as pi by 2 and then minus pi by 2, then it will be pi. The correct option for this is C. Uh, Question 21. I will take this as I integration 0 to pi by 2 log 4 plus 3 sin x upon 4 plus 3 cos x dx. So using property 5, I will replace x by a minus x. Here a is pi by 2. So I will replace this by pi by 2 minus x. You know that pi by 2 will change the function, and as pi by 2 minus is going in first quadrant, sign will not change. So I will get 4 plus 3 cos x upon 4 plus 3 sin x dx. If this as 2, adding equation 1 and equation 2, I will have I plus I will give me 2I. Will take common integration as both of them is having the same limit, log 4 plus 3 sin x upon 4 plus 3 cos x plus log 4 plus 3 cos x upon 4 plus 3 sin x whole dx. Now we'll apply the property of log. If I want to take common log, then as these two log are in addition, I will take common log and will multiply them. Right, so we'll multiply. And this will get cancelled out, and this will get cancelled out. So I'm left with log 1, and log 1 is 0. So 0, as log 1 is 0, whole integration will only become 0. So as the value of 2i is 0, value of I will also 0. Right. Here the best option or the correct option is option C.